Welcome learners. In this lecture we are going to discuss diagrammatic and graphical representation of data. After completion of this lecture, you are able to learn about data presentation tools and classification of tabulation of data, diagrammatic representation, the collected data to be represented in the form of diagrams and graphical presentation like histogram, frequency polygon, frequency curve and ogive curves. We have already discussed the data collection methods, that is primary data and secondary data with their merits and demerits. The data collected is crude in the form. It is to be refined for further statistical analysis. First, the data should be classified and then it is to be tabulated. There are four types of classifications. One is chronological classification. It is classification according to the time, and geographical classification. It is classification based on the locality or area of the data. And next is qualitative classification and then quantitative classification. The why classification is needed. Arranging the data groups or classes on the basis of certain properties is called as data classification. It condenses the raw data, reveals the patterns of the variable, compare and find some facts between the groups, establish relationships between the groups or variables to present data in orderly form for statistical analysis. There are some rules of classification. There should not be unambiguous. It is exhaustive. It is to be stable for the purpose, suitable for the purpose, and flexibility. These are the four types of classifications. Okay, the temporal classification is classification according to time. Look here, this is year and population in crores. The spatial classification is geographical classification. It is the classification according to the regions. Nellore, Vijayawada, Warangal, Karimnagar, Hyderabad. Sales of TVs. It is another geographical classification. Next is classification of qualitative data. Data is qualitative in the form. Qualitative means it is not measured, it is compared only. Very much dissatisfied, neither satisfied nor dissatisfied, satisfied, very much satisfied. This is the stages. Here, these are the numbers. They cannot say it is in figures. We cannot measure these satisfaction levels in the form of figures. We can classify them in the form of quality. There are 5 stages. Very much satisfied is the highest stage. Very much dissatisfied is the last stage. Next is quantitative classification. Most of the statistical analysis is for quantitative data only. That's why our statistics is called quantitative techniques. In B.Com, they call it as quantitative techniques. Okay, this is number of children, number of families, frequency distribution. After classifying, we have to construct a frequency distribution. Frequency distribution for qualitative data. This is about qualitative data. The rating, poor. Poor is frequency 2. Below average, frequency 4. Like that. We can construct the relative frequency also. This is the relative frequency. Total is 20 here. 6 plus 3, 9, 9 plus 9, 18, 20 here. 2 by 20 is 10 is the relative frequency. Relative frequency for poor rating is 0.10. Relative frequency always lies between 0 to 1. Nothing but probability. Frequency distribution for quantitative data. We all know the construction of frequency distribution table. This is the raw data. We need to find the number of accidents. This is the tally marks. This is the frequency. 0 accidents, frequency 20. For 3 accidents, frequency is 1 from this table. We have to construct tally marks, and by adding the tally marks, we can get the frequency. This is discrete frequency data. Whereas class interval, we have, this is the class interval and frequency. In class interval, there are upper and lower limits. There are different types of class intervals, inclusive classes. Here, inclusive classes means both lower boundary and upper boundary include for calculation. Whereas in exclusive classes, upper boundary excluded. Generally, 10 is excluded from the first class. 20 is excluded from the second class, like that. Another types of frequency distributions are also there. Open-end frequency distributions, frequency distribution with unequal class intervals, cumulative frequency, relative frequency distributions. This is open-end classes. Here, for the first class, there is no lower boundary. This type of interval classes are called open-end classes. We cannot find lower limit here. Also, we cannot find the mid value for this class, particular class, and we cannot find mean, geometric mean, harmonic mean for this type of data. Whereas median and mode can find for this data. So, look here, the last class have no upper boundary. More than 40. What is the upper boundary? We cannot know. And frequency with unequal classes. Here 0 to 10, 10 to 20. These are the equal class intervals. There are unequal class intervals also. 0 to 10, 10 to 20. These are equal class intervals. This is relative frequency. Class frequency by total number of values. This is cumulative frequency. You all know cumulative frequency 18 plus 5, 23 plus 3, 26, like that. These are the less than cumulative frequencies and these are the greater than cumulative frequency. In case of greater than cumulative frequency, we add the frequencies from lower to upper. These are the less than cumulative frequency, greater than cumulative frequency. Okay. Generally, for calculating median, we find less than cumulative frequencies. For constructing ogive curves, we need both less than and greater than cumulative frequencies. Here, the construction of frequency distribution table, find the range. We have to find the class width, decide the class width by range divided by number of class intervals. The number of class intervals also carefully decided. There should not be less than 5 classes and more than 15 classes. This is the one example for constructing of frequency distribution. Okay, approximately 9.83 means we round it off 10 class intervals. Class interval is 10 here. Okay, after this there is tabulation of data. The first we need to classify the data and then tabulation is required. This is tabulation of data. Of course, the classification and tabulation is not there in our syllabus, but we use all these concepts in our statistical techniques. So I am just briefing all these concepts. This is tabulation, imports and exports. Here we have years and countries, imports, exports, yearly imports and exports. There are the objectives of tabulation is it simplifies the complex data. The data presented in the form of table reveal the trend or pattern of the data. Tabulation facilitates quick comparison. It helps in reference for further future needs. There are reference tables, text tables or specific purpose tables, like that. There are some features of table. A table should be having table number, title of the table, head note, stubs. Stubs are the headings of the rows. Stubs are used to designate rows. The headings of the rows is called stubs, and captions are also called box head. main body, footnote. These are the main prerequisites for a table. Okay. Here, this is the form of a table. Head, subhead, column head, caption, subheading, subentries, total, footnote, source note. We should mention from where the table is to be collected. Remarks also should be mentioned. These are the importance of table. After the classification and tabulation, we must look into the diagrammatic representation of data. This diagrammatic and graphical representation is, this PPT is downloaded from internet, LinkedIn, and introduction of diagrammatic representation of data. This is there in our syllabus. One of the most convicting and appealing ways which statistical results may be presented is through diagrams and graphs. Just one diagram is enough to represent a given data more efficiently than 1000 words. Just by looking the diagram, we can understand what is there in the data. It is easy to understand diagrams even for ordinary people. Illiterate people also can understand from diagrams. A diagram is a visual form of presentation of statistical data highlighting their basic facts and relationships. If we draw diagrams on the basis of the data collected, they will easily be understood and appreciated by all. It is readily intelligible and save a considerable amount of time and energy. The significance or importance of diagrams and graphs. They are attractive and impressive. They make data simple and intelligible. They make comparison possible. They save time and labor. They have universal utility. They give more information. They have a great memorizing effect. General rules for constructing diagrams. It should be neatly drawn and attractive. The measurements of geographical figures used in diagrams should be accurate and proportional. The size of the diagrams should match the size of the paper. Every diagram must have a suitable but short heading. The scale should be mentioned in the diagram. Diagram should be neatly as well as accurately drawn with the help of drawing instruments. It should not be drawn with freehand curves. Index must be given for identification. Every diagram should be numbered and a footnote must be given at the bottom of the diagram. Economy in cost and energy should be exercised in drawing diagram. There are these type of diagrams are there: one-dimensional diagrams, two-dimensional, three-dimensional, pictograms and cartograms. The one-dimensional diagram. There is line diagram, simple bar diagram, multiple bar diagram, subdivided bar diagram and percentage bar diagram. There are 5 types of diagrams. Let us look at these diagrams one by one. This is line diagram. Used in case of there is many items to be shown and there not be much in difference in their values. Such diagram is prepared by drawing a vertical lines, just vertical lines. This is number of children and frequency represented here. It makes comparison very easy, but it is less attractive. Next one is simple bar diagram. It is very much useful. It can be drawn either horizontal and vertical. Bars must be uniform width and intervening space between bars must be equal. While constructing a simple bar diagram, the scale is determined on the basis of the highest value of the series. To make the diagram attractive, the bars can be colored. Bar diagrams are used in business and economics very well. This is simple bar diagrams. This is the data. For this data, the simple bar diagram is like that. Here, this is equally spaced. Here is in x-axis and production is shown in y-axis. Then next one is multiple bar diagram. Multiple bar diagram is used for comparing two or more sets of statistical data. Bars are constructed side by side to represent the set of values for comparison. They should be constructed side by side for easy comparison. In order to distinguish bars, they may be either differently colored or there should be different types of crossings or dottings, etc. An index is also prepared to identify the meaning of the different colors or dottings. This is the problem for multiple bar diagram. Here the profit in before tax profit after tax. We can compare easily by drawing multiple bar diagram. Here the profit. This is before tax. The dotted one is before tax. Before tax, the profit is very high. After tax, it is less. Profit is reduced year by year. Okay, easily compared. Subdivided bar diagram. A subdivided bar diagram, it is subdivided into various parts in proportion to the values given in the data, and the whole bar represent the total. Here, it is nothing but a simple bar diagram. We subdivide it into different components. Such diagrams are also called component bar diagrams. The subdivisions are distinguished by different colors or crossings or dottings. The main defect of such a diagram is that all the parts do not have a common base to enable one to compare accurately the various components of the data. Here is the example for subdivided bar diagram. Here is food, family A 75, family B 95. For family A, all these values subdivided. Yeah, for food is this. Food is 75. Clothing is, yeah, education, this type of dots. Okay, for family A, these are the subdivisions. Monthly expenditure shown here. Subdivided bar diagram is drawn like, okay. Next one is percentage bar diagram. The components are not actual values but percentages of the whole. We convert the items into percentages in percentage bar diagram. The bar length is 100 in percentage bar diagram. The main difference between the subdivided bar diagram and percentage bar diagram that in the former the bars are of different heights since their totals may be different, whereas in the later the bars are equal height since each bar represent 100%. In the case of data having subdivision, percentage bar diagram will be more appealing than subdivided bar diagram. Here we must convert the items into percentages here. Factory A total, selling price, quality sold, wages, like this. We must convert all these into percentages. The formula for converting items into percentage is item value divided by total of all items into 100. This is the formula used. Total is 7640 here. 400 divided by 7640 into 100 gives us 5%. Like this. Okay. By using the formula, we can convert all these values into percentages. Then this is the subdivided percentage bar diagram. Factory A, factory B, these are the percentages. Next is two-dimensional bar diagrams. Here up to degree level we can having only 5 types of diagram: line diagram, simple bar diagrams, multiple bar diagram, subdivided bar diagram, and percentage bar diagram. You can learn this also: rectangle, squares, pie diagrams. These are the rectangles. This is the rectangle diagram. Subdivided percentage rectangular diagram. This is square diagram and pie diagram. Okay, this is very important. Here pie diagram, it is similar to percentage bar diagram, but here it is the circle. The circle is subdivided. The total degrees in the circle is 360 degrees. We divide the 360 degrees into sectors by using the formula item divided by total of items into 360 here. Whereas in percentage we multiply with 100. Here the quantities in degrees. This is the quantals. Cuba 62 means 62 divided by 360 gives us 134 degrees. Okay. Three-dimensional diagrams. We have these are the three-dimensional diagrams: undergraduate, postgraduate, and professional. Pictograms are the diagrams depict the kind of data. These are the drawings. These are the figures actually. Next one is graphical representation of data. This is important for us. A graph is a visual form of presentation of statistical data. A graph is more attractive than a table of figure. Even a common man can understand the message of the data from the graph. Comparisons can be made between two or more phenomena very easily with the help of a graph. There are these types of graphs: histogram, frequency polygon, frequency curve, Wajib. Lorentz curve also there, but it is not in our syllabus. Histogram is a bar chart or graph showing the frequency of occurrence of each value of the variable being analyzed. In histogram, data are plotted as a series of rectangles. Class intervals are shown in the x-axis and the frequencies are in the y-axis. The height of each rectangle represents the frequency of the class interval. Each rectangle is formed with the other so as to give a continuous picture. Such a graph is also called staircase, or it is staircase. It is just like a staircase, steps, or block diagram. We cannot construct a histogram for distribution with open end classes. In this, we cannot decide the upper limit and lower limit. It is also quite misleading of the distribution has unequal intervals and suitable adjustments in frequencies are not made. This is the example for constructing histogram. Here is the class interval 0 to 50. 50 is the class limit here and number of workers. Look here, 0 to 50, first class, 8. Number of workers, 8 here. 50 to 100, it is just like steps you can find. This is the highest frequency. For 150 to 200, 100 to 150, 27 is the frequency. We can find this is the highest bar here. The bar constructed adjacently. Okay, daily wages in rupees. It is just like staircase. Frequency polygon. If we mark the midpoints of the top horizontal sides of the rectangles of a histogram and join them by a straight line, the figure so formed is called as a frequency polygon. This is done under the assumption that the frequencies in a class interval are evenly distributed throughout the class. The area of the polygon is equal to the area of the histogram because the area left outside is just equal to the area included in it. Look here, this is the histogram. To draw frequency polygon, we must construct histogram first. The midpoints of the bars is noted and joined by straight lines. This is the histogram. This is the frequency polygon. This is the example. Number of students, weight. This is the zigzag curve. This is the frequency polygon. Next one is frequency curve. If the middle points of the upper boundary of the rectangle of a histogram is corrected by a smooth freehand curve, then that diagram is called frequency curve. The frequency curve plays very important role in all finding the nature of skewness, the extent of data frequency distribution, the frequency curve, the shape of the frequency curve gives us lot of information about the data. Look here, this is the frequency curve. Must be smoothly drawn. Okay, next is Wajib curves. The Wajib curves are also called less than or greater than cumulative frequency curves. For a set of observations, we know how to construct a frequency distribution. For some cases, we may require the number of observations less than a given value or more than given value. It is obtained by accumulating, adding the frequencies up to or above the given value. This accumulated frequency is called cumulative frequency. Just like these cumulative frequencies are then listed in a table and called cumulative frequency table. The curve table is obtained by plotting cumulative frequencies is called a cumulative frequency curve or an Wajib. The Wajib is two types, less than Wajib and more than Wajib. Less than Wajib, for drawing less than Wajib, we start with the upper limits of the classes. Look here, upper limits is used to construct less than Wajib. Lower limit is used to construct more than Wajib. This is the only difference. This is the example, classes interval frequency. We must find less than cumulative frequencies greater than cumulative frequency. The class limits, the frequencies are added from 4, 4 plus 6, 10, 10 plus 13, 23 like that. 4, 20, 23 like that. This is we added from back side. This is the construction of less than and greater than ogive curves. Here for 20, 0. Next is 23 like that. This is less than ogive. It is greater than. The intersecting point here added such as x-axis gives us median. This is about the graphical representation of data. Okay, here in this lecture we have we learned about data presentation tools, classification and tabulation of data, diagrammatic representation of data, and graphical representation of data. Okay, thank you.